Okay, let's unpack this. When we talk about the global pollinator crisis, the story we usually tell is, well, it's pretty simple and honestly a little comforting, isn't it?
It usually has a clear narrative.
Exactly. It has a clear enemy, pesticides, habitat destruction, industrial farming, and it usually has a clear hero, the bee.
Right. The honeybee,
Yes.
specifically, Apis mellifera.
Yes, the Western honeybee. We love the honeybee. I mean, we've really elevated it to this symbol of environmental salvation.
We absolutely have.
People putting hives on city roofs, in their gardens, even in nature reserves, really believing, that we're helping save the planet one jar of local honey at a time.
And that deeply embedded narrative, the one with the honeybee as the universal environmental savior, that's precisely what makes the topic of this deep dive so
Well,
jarring and
yeah,
so necessary.
yeah.
We are wading into a genuine, pretty nuanced conflict here. It's a scientific and political struggle mostly playing out across Germany right now. And it involves respected, powerful conservation groups who are actually demanding the state impose strict regulations on the population density of that exact same beloved honeybee.
It sounds totally counterintuitive. Like, why would conservation groups criticize the honeybee?
It does, and we have some really comprehensive source material for this. An intense analysis looking at the scientific, the financial, and the political arguments
Used by whom?
by major German organizations like NBU, that's Naturschutzbund Deutschland, and the Deutsche Wildtierstiftung.
Hmm.
Big players.
Right. And crucially, they're not asking for beekeeping itself to stop, are they?
No, absolutely not. That's key.
Right.
They're calling for binding limits on how many hives can actually be placed in certain locations,
Yeah.
specific places.
Okay. So our mission today then is to move beyond the emotion of that, save the bees slogan and really understand the cold, hard ecological facts behind this. We need to dissect why these groups dedicated to preserving nature, are now criticizing an organism that's so central to the public idea of ecosystem recovery.
Exactly. And the core tension, as the source material makes really clear, isn't actually against the species Apis mellifera in its natural state.
Right.
It's against the unnaturally high density of these highly efficient generalist honeybees, especially when that density gets concentrated in very specific sensitive habitats,
Like where?
like small protected nature reserves or maybe the green spaces within urban centers. These zones are often the last sort of desperate refuge for struggling native wild bee populations.
So it's like the ultimate good deed gone wrong, where maybe overzealous introduction of what's essentially a powerful livestock animal
Yeah, that's the framing.
into a limited ecosystem is creating this unexpected, localized threat.
That's a really good way to put it. It's the concentration and the location that's causing the friction.
Okay, so to really grasp why conservation groups feel they have to regulate the honeybee now, we first need to appreciate the backdrop. I mean, it's pretty apocalyptic.
The severity of the global insect decline.
We're not just talking about small dips in population here. We are talking about a potential ecological collapse that seems to require, well, emergency triage.
Absolutely. The scientific foundation for this entire political debate rests on some truly dramatic data.
Hmm.
I mean, the absolute shockwave was that Kreisfeld study back in 2017.
Oh, yeah, I remember that one. Huge impact.
Huge. It was based on decades of tracking, and it showed an average decline in flying insect biomass, just the sheer weight of insects of roughly 80%.
80%.
In certain parts of Germany over just a few decades. That data revealed a collapse on a scale that just shattered the old notion that conservation could be passive. It forced conservationists to look at every single variable.
Every possible factor contributing to habitat strain.
Exactly, no matter how politically inconvenient it might be.
And when you start analyzing the causes of this decline, you immediately see why the political system is kind of gridlocked, don't you?
You do. It's not one single cause. It's this disastrously complex web. When we look at the undisputed primary drivers, the ones identified by, say, the IPBES framework.
That's the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services.
That's the one. We see a list of systemic forces that are just incredibly difficult to reverse quickly.
Like what? What are the big ones?
Okay, so first, massive habitat loss.
Yeah.
Paving over everything,
You
drained
would
it.
have meant, yeah.
Second, the widespread, intensive use of chemical pesticides, coupled with these vast agricultural monocultures.
Yeah.
Just seas of one crop.
Nothing for diverse insects to eat there.
Nothing. Third, the pervasive destabilizing effects of the climate crisis. changing bloom times, weather patterns,
Uh-huh.
and fourth, new parasites and pathogens, especially the varroa mite for honeybees, which decimates managed colonies and creates instability even within the managed pollinator sector itself.
That multi-causality, that's the root of the policy paralysis, isn't it?
I think so.
Because if the problem were just, say, industrial pesticides, you could maybe pass strong legislation to ban them.
Right.
Theoretically, yes,
Right.
a single target. Or if it were just climate change, you could focus all energy on, well, energy policy. But because it's 4 or 5 massive drivers, all interwoven, touching every sector of the economy, systemic reform becomes politically just overwhelming. It's so hard to assign clear responsibility or implement sweeping change because the solutions require overturning really foundational economic structures.
And that political difficulty, that's the strategic heart of the conservation group's dilemma here.
Mm-hmm.
Radical reform of industrial agriculture.
Yeah.
Which, let's be clear, is widely seen as the main cause of that 80% decline,
Right.
is currently blocked by massive political and economic inertia. It's just stuck.
So because this big systemic change is so politically difficult, almost impossible in the short term,
Yeah.
conservation groups are kind of forced to turn their attention to factors that are more local, immediate, and, this is crucial, manageable.
Exactly. Manageable. And in that complex, high-pressure environment, the localized density of Apis mellifera in these specific sensitive areas becomes, well, a surprisingly controllable factor.
Ah, okay. So the critique of the honeybee isn't necessarily a distraction from the main fight.
Yeah.
It's more like a necessary response to the fact that they might be losing the main fight, or at least it's stalled. It's like triage.
It is entirely triage. The critique, viewed in this sense, is an emergency management strategy. It's designed to secure the last vestiges of native biodiversity under these extreme high-stress conditions.
They have to secure the local refuges because they can't secure the vast agricultural landscape right now.
That's the logic, precisely.
Okay, let's really nail down the identity of the organism at the center of this debate.
Yeah.
We're talking about Apis mellifera, the western honeybee.
Mm-hmm.
Now, this species is indigenous to Europe, Africa, parts of Asia. It's been pollinating these landscapes for millennia. So if it's a native species, why is its mass presence suddenly such an issue?
Yeah, that's a fair question. And the distinction that underpins the whole conservation argument is both legal and functional. While A. mellifera is indigenous, the organizations are focusing on its status and its management today. In Germany, and functionally across much of Europe, it's classified as a domesticated livestock.
A Nutztier.
Nutztier.
Livestock. Okay.
This classification legally frames it as, well, a resource managed for human gain honey. Pollination services separate from the wild fauna, the wild tier.
So the argument boils down to beekeepers are essentially livestock farmers, and their livestock is now competing with native wildlife.
That is precisely the claim being made. The conservation groups draw a sharp line legally and ecologically between the small, natural density of wild honeybee colonies, which would regulate their own numbers based on available resources,
Right, like a wild population would.
and the mass presence that results from human management. I mean, think about it. A beekeeper can introduce a colony of 30, 60, maybe even 80,000 individuals
Huge numbers.
into a small protected forest, basically with the turn of a key, moving a hive box. This is the definition of artificially generated high density.
And this artificial density, it's often intentionally introduced into these sensitive ecosystems for a couple of main reasons, right?
Mhm.
One, beekeepers want to protect their valuable hives from the pesticides that are so prevalent in the wider agricultural landscape.
That's a big one. Economic self-preservation.
And two, they're actively seeking better, more diverse forage areas for their bees, which are now, ironically, disproportionately located in cities and these protected zones.
Exactly. So the criticism isn't based on some kind of species-specific hatred. The groups are not arguing that A. mellifera should be eradicated or anything like that.
Duh.
They're arguing against the scale and the placement of this managed animal. It's this artificially high density that fundamentally alters the ecosystem balance,
Creating what?
creating overwhelming resource competition and, critically, increasing the risk of pathogen transmission diseases spreading to the much more fragile wild species that are barely holding on in those same areas.
So the sheer non-native level of numbers is the problem, not the natural bee itself in its wild state.
Exactly. It's the concentration.
Okay, here's where it gets really interesting, I think. Because the conservation organizations, they aren't just, sounding an alarm based on gut feelings or maybe anecdotal observations of a few bees fighting over a flower.
No, not at all.
They seem to be building their entire argument on a foundation of current, peer-reviewed, independent scientific literature, essentially saying, look, we are just following the data, and the data tells us we have a real problem here.
They have absolutely done their homework on this. They're basing their political position on major recent meta-analyses.
Okay, meta-analyses. What does that mean exactly?
So these aren't just single studies done in one location. They are comprehensive reviews, like the work published by Arst and colleagues in 2023, or analyses by Gratzer and Brodschneider. They synthesize findings from hundreds of individual studies conducted globally.
Right, pulling it all together.
Exactly. And this large body of work confirms pretty definitively that the competition between managed honeybees and native wild bees isn't some artificial or purely theoretical construct. It is, and they use this phrase, a real, measurable ecological risk.
Okay. And what kind of studies do these meta-analyses look at? How do they actually reach that conclusion that the risk is real?
They mainly look at two types of studies across different ecosystems, different biomes. First, they're observational studies.
Like watching what happens.
Basically, yeah. Researchers monitor flowers. They record displacement rates, literally measuring how often a bigger, more numerous honeybee physically bumps or drives a smaller wild bee off a flower.
Okay.
Second, and this is maybe more important for establishing causation, they look at experimental exclusion studies.
How do those work?
In these experiments, researchers will intentionally remove managed honeybee colonies from a specific habitat or maybe fence them off somehow.
Right.
And then they measure what happens to the local wild bee populations. Do they recover? Does their foraging success improve when the honeybees are gone?
I see. Comparing with and without.
Exactly. And it's the consistency of these results, seeing similar patterns across different regions, different plant types, that really establishes the scientific consensus.
Okay, so what is the core scientific finding then? The one that justifies these demands for regulation? What percentage of studies actually shows a negative impact?
Well, the finding is compelling, and it's a metric that really gets attention in these policy debates. These meta-analyses show that in over 50% of the scenarios examined globally,
Over half.
yes, over half, the sheer presence and density of managed Apis mellifera had measurable negative effects on wild bee populations.
Wow. Okay, that's significant.
It's a critical threshold. It means competition isn't some rare fluke event you can just ignore. It's actually a common ecological outcome under specific conditions.
So a 50% negative impact rate really confirms that the competition is structurally significant. We've kind of moved past debating if competition exists.
Right. The science is pretty clear on that.
To regently needing to define where and how intensely it exists. Hashtag 2.2. The context dependency of the risk hotspots.
And that analytical distinction, the where, is absolutely essential to understanding the conservation strategy here. The danger isn't uniform across the entire landscape.
Okay.
It is highly context dependent, which is why the proposed regulations are geographically targeted, not just a blanket ban.
Makes sense.
The scientific literature confirms that in large, healthy, florally diverse landscapes, think huge, sustainably managed wildflower meadows or regions with just abundant, diverse natural forage.
Lots of flowers everywhere.
Right. In those situations, competition is often negligible. There are simply enough resources, enough flowers to dilute the effect of the honeybee colonies. Everyone gets enough.
But then we have the risk zones, the hot spots that groups like NEBU and the DWS are really focusing on. Where exactly are the places most vulnerable to this hive density issue?
They are focusing their concern primarily on areas where floral resources are either naturally scarce or maybe they're just spatially constrained, hemmed in.
Okay, like what kinds of places?
First, think of flower-poor, spatially limited protected areas. These could be small nature reserves, maybe little islands of biodiversity surrounded by vast, unproductive agricultural land.
Right, like an oasis.
Exactly. And for beekeepers, these islands look like ideal safe havens. They're pesticide-free, maybe have some diversity, but ecologically they are small, enclosed systems with limited carrying capacity.
I see. And the second major hotspot?
Second, and this is increasingly crucial, and maybe surprising to some, are urban centers, cities.
Yeah, the urban angle does feel counterintuitive to many people, especially those embracing rooftop beekeeping. Cities are often celebrated now as these new biodiversity havens.
And in some ways they are.
Because the lack of widespread intensive chemical spraying means they are generally safer than the countryside for insects.
They are safer from chemicals, that's true. But that very safety acts like a magnet for beekeeping. The moment every resident, every corporation, every hotel decides, hey, let's put 1 or 2 hives on our roof for the environment, That small, localized refuge of floral resources, the parks, the balcony boxes, the street trees, is suddenly assaulted by potentially tens of thousands of highly efficient foragers per square kilometer.
Okay, the density skyrockets.
It skyrockets. And this can quickly turn a chemical safe haven into a competition disaster zone, particularly for those highly constrained solitary wild bees living there. The pressure cooker effect is immediate and really intense in these defined, tight urban areas. Hashtag TagTag 2.3. The asymmetry of resource consumption.
Let's try and quantify this pressure then. If the competition is real, why is one single honeybee colony so much more disruptive than, say, 100 solitary wild bees living in the same area?
It has to come down to scale, right?
Yeah, and life cycle, resource demand.
It is the crucial, almost overwhelming difference in resource logistics.
Absolute.
A strong honeybee colony is eusocial. It operates like a single superorganism,
Right.
housing maybe 50,000, sometimes up to 80,000 individuals during the peak of summer. And critically, it's perennial.
Meaning it lives year-round.
Yes, it's active year-round, or at least the colony structure persists. It requires immense stores of pollen and nectar, not just for immediate feeding of the current workers and brood, but to survive the winter and then kickstart the whole operation again next season. The colony is constantly collecting resources for future use, stocking up.
It's like they're a highly capitalized company with massive inventory stores, always running on a global supply chain logic almost.
That's a great analogy, precisely. Their sheer collective demand for pollen and nectar is just immense. It operates at a level that no collection of individual solitary insects could ever possibly match.
And this is the defining aha moment, isn't it, for understanding the quantitative scale of the problem.
I think it is.
Can you give us that specific data point, the one that really illustrates this massive asymmetric burden on local resources?
Yeah, we really have to look at the calculations quantified by researchers like Kane and colleagues back in 2017. Their findings illustrate the scale, and it is pretty devastating when you think about it.
Yeah.
The theoretical pollen requirement of just one strong, highly efficient honeybee colony, just one, is sufficient to raise 100,000 average wild bee offspring.
100,000. Wow. So one managed livestock unit, one hive, is potentially consuming the life resources needed to sustain a population of 100,000 individual wild bees.
That's the potential resource footprint, yes.
That really transcends simple competition. That sounds more like an ecological vacuum cleaner being introduced into a sensitive ecosystem.
It's an asymmetric resource battle, and frankly, the solitary bees never really stood a chance in these high-density scenarios. Think about the solitary bee. She's collecting only enough pollen for her immediate one-off reproductive effort.
Just for her own kids.
Right. A few grams per year maybe, provisioning perhaps 10, maybe 20 individual nest cells. That's it. The honeybee colony needs kilos of pollen. It stores its production for months, potentially a year ahead.
Huge difference in scale.
Massive.
Yeah.
So when you multiply that single colony's impact by the numerous hives often placed together by commercial keepers, or by the proliferation of backyard beekeeping in small city parks, the resulting pressure on those local floral resources becomes mathematically unsustainable for the wild species that have to operate with absolute reproductive precision right there, right then.
The generalist honeybee's efficiency is just too good. It's too effective at exhausting the available food supply in that local patch.
Exactly. Especially when that patch is limited to begin with.
Okay, so we've established the quantitative evidence at staggering 100,000 offspring equivalent. Now we need to dig into the qualitative differences, the life strategies, because that explains why the wild bees are losing this fight so fundamentally, even if they share the same space sometimes.
Yeah, we're looking at a really fundamental divide in biological strategy here. Section 6 of the conservation analysis often details this. Let's start with the honeybee again, A. mellifera. It's built for resilience, for efficiency, for scale. It's eusocial, living in these vast, organized colonies. And crucially, as we touched on, it is a generalist. It's polylectish.
Meaning it feeds on many things.
Exactly. It can feed on virtually any available floral source pollen or nectar from hundreds of different plant species. It's not picky.
A true opportunivore. Adapts to whatever is available.
Absolutely. Yeah. And its mobility is just staggering. It's a long-distance forager. It's capable of flying up to 10,000 meters, that's 10 kilometers.
10 kilometers.
In a radius from the hives to find food. The colony structure means its robust losses of individual workers are easily compensated for by the sheer numbers. And as we said, it's active year-round, living off stored reserves.
It really is the ultimate biological survival machine, isn't it? Like a marathon runner with a universal buffet card, completely buffered against local failure because it can just fly further.
That's a good way to think about it.
Yeah.
Now, contrast that strategy with the vast majority of wild bees. About 90% of bee species are solitary.
90%.
Yes. A single, often quite small, female bee is responsible for the entire fragile operation.
Everything herself.
Everything. Finding the nest site, maybe digging it or finding a cavity,
Yeah.
building the individual nest cells, collecting all the pollen and nectar needed, provisioning the brood, laying the egg, sealing it up. The loss of that single female at any point
Means total failure for that generation.
all generational failure.
Yeah.
There's no colony buffer, no backup workers.
And many of them are the complete opposite of the honeybee's feeding strategy too, right? Not generalists at all.
Exactly. Many wild bees are highly specialized. They're oligolectish.
Oligo what?
Oligolectish, meaning they rely entirely on pollen from very specific plant families, sometimes even narrow genera or single species.
Oh, wow. Picky eaters.
Extremely. The source material gives a great example. The specialized Osmia dunca bee. It absolutely requires pollen from Achium plant Viper's bug gloss for its larvae to develop properly. No Achium, no baby bees. So, they are fragile. They cannot compensate for individual loss. And crucially for this competition issue, they are almost always short-distance foragers.
How short?
We're talking maybe flying only a few hundred meters, typically less than 300 meters from their nest site.
Yeah.
That's their entire world for finding food.
So their whole existence is incredibly precarious. It's tied to a very small, very specific, and often completely non-negotiable patch of resources right near their home.
Precisely. It's a life on a knife edge.
Yeah.
Hashtag tag 3.2. The vulnerability of the wild bee niche. And that short, specific flight distance, that few hundred meters, that is the single most critical vulnerability that the honeybee inadvertently exploits in these high-density situations.
Okay.
We really need to spend a moment on the mechanism of harm here, because this is where the policy recommendations like buffer zones come directly from.
Right. How does it actually hurt them?
For that solitary wild bee, nesting success is inextricably linked, completely tied to the floral resources located in the immediate 200 to 300 meter radius of her nest hole.
Her little neighborhood.
Her tiny neighborhood. She is geographically and botanically constrained. She can't just decide to fly 5 kilometers if the local flowers are gone.
Whereas the honeybee, with its massive 10-kilometer foraging radius, can easily fly past 9.7 kilometers of, say, chemically treated barren monoculture farmland, reach that small patch of diverse flowers in a municipal park or nature reserve, clean it out completely, and then fly all the way back home to the hive.
Exactly. The wild bee living in that park cannot do that. The wild bee must be able to provision its brood immediately nearby.
Okay.
And so the devastating mechanism of harm is the resulting reduced brood success.
Meaning fewer babies survive.
Or none at all. If the mass density of Amylifera, tens of thousands of them, is introduced into that tight ecosystem and exhausts the resource supply within that critical 300-meter radius, even if only partially but significantly,
Yeah.
the solitary wild bee female simply cannot compensate by flying farther. She doesn't have the energy reserves or the programming. She would expend all her energy searching, flying around looking for pollen.
Wasting time and energy.
Right. And she returns with insufficient pollen to properly pack the larval cell. The brood provisioning fails directly. The egg might still be laid, but the larva effectively starves before it can develop and pupate.
Oh, wow. So the competition isn't just about, two adult bees maybe fighting over a flower and one trying to survive. It's actually about triggering reproductive failure for the entire wild bee lineage in that specific local spot,
Yes.
caused by the localized resource exhaustion generated primarily by the managed honeybee colony.
That is the essential ecological difference and the core of the conservation concern. The honeybee colony, if local resources run low, just redirects its foragers kilometers farther away, taps into its stored reserves, survives the winter, and tries again next year. The colony persists.
Right.
The solitary wild bee female, often a specialist tied to that one spot and those few plants, effectively starves her single reproductive effort right where she stands, and that leads directly to the local decline or even local extinction of that specific population.
That ecological asymmetry, it's brutal.
It is. And it's why the conservation groups argue that regulating local honeybee density isn't just, a nice idea. It's an absolute necessity for ensuring wild bee survival in these last remaining refuge habitats.
Yeah.
Hashtag 3.3. additional mechanisms of negative impact.
Okay, so beyond this really profound resource asymmetry and the resulting brood failure, the source material points to three major mechanisms confirmed by science by which honeybees negatively impact their wild cousins. We've covered reduced brood success pretty thoroughly now.
Yes.
Let's look a bit closer at the other two. Resource exhaustion and active displacement, and also pathogen transmission.
Right. So the first detailed mechanism is that resource exhaustion and active displacement. Because honeybees operate in such overwhelming numbers, just the sheer biomass of foragers coming from a single hive.
It's a crowd.
It's a crowd. They are physically dominant at the flower. Studies actually show them actively displacing even larger wild bee species, like certain bumblebees, from key floral resources just by crowding them out or being more aggressive.
Okay. And we noted earlier that this displacement effect is especially critical late in the season. Why does the timing matter so much?
That's a really important point. Because early in the year, say spring or early summer, you often have these massive seasonal blooms. The term is massentrachten.
Like rapeseed fields or orchards.
Exactly. Huge areas flowering all at once. During this time, the sheer volume of floral resources often exceeds the immediate demand. Even with many honeybee colonies present, there's usually enough to go around.
Plenty for everyone.
But once those mass blooms are finished, later in the summer or fall, the generalist A. mellifera, driven by the colony's need to keep storing resources, turns its highly efficient attention to the sparser, often more specialized floral resources. The very resources that might have been the exclusive or primary food source for specialized wild bees earlier on, or the ones they rely on to finish their nesting cycle.
Ah, okay. So the honeybee essentially cleans out the easy, abundant, generalized resources first, and then, driven by its 10-kilometer hunger and huge colony demand, it moves in to clean out the specialized larder right when the wild bees desperately need those last bits to finish raising their young for the year.
That's the dynamic.
Yeah.
Precisely. They are the ultimate competitor, especially when resources become scarce later in the season. The second mechanism, as we established, is that reduced brood success due to the wild bee's inability to provision its nest when that critical 300-meter perimeter gets depleted.
Got it. And the third mechanism, this is a direct health risk, right? Pathogen transmission.
Yes. Disease spread.
Specifically, the transfer of viruses like the deformed wing virus, DWV. How does the managed honeybee population act as a risk accelerator for wild species like bumblebees?
Yeah, this is a really deep ecological concern that's getting more attention. Managed honeybee colonies, because they're so dense and numerous, essentially act as huge concentrated pathogen sinks and distributors.
Reservoirs of disease?
Exactly. And the close genetic relationship between Apis mellifera and many wild bee species, especially bumblebees, bombus species, allows for spillover of these pathogens. Viruses jump between species.
How does the spillover happen?
The deformed wing virus, for example, while often survivable for a large, robust honeybee colony, gets transmitted primarily through shared floral resources.
On the flowers themselves?
Yes. Through physical contact with contaminated pollen or nectar left on a flower by an infected honeybee, a wild bee visits that same flower shortly after.
And picks up the virus.
Precisely. So the more concentrated the managed honeybee colonies are in an area, the higher the overall viral load is likely to be on the flowers in that area.
And the poor wild bees are basically forced to forage on that contaminated food supply because it's all that's available in their limited range.
That is exactly the dynamic. And the wild species, particularly the fragile solitary bees and also socially stressed bumblebees, often have less exposure diversity throughout their evolutionary history. Their collective immune response might be less robust compared to the honeybee, which has been managed and exposed for centuries.
So they're more susceptible?
Often, yes. When they pick up DWV or other pathogens from the overwhelming density of managed colonies nearby, their populations can be further destabilized. It weakens their ability to survive the winter or for bumblebees to successfully raise new queens.
So it's like a 1-2 punch.
It really is. They're potentially resource-starved and made sick by the overwhelming biomass of the managed livestock introduced into their environment.
Okay, so this issue isn't just confined to, specialized scientific journals. It's clearly become a full-blown political and conservation fight, and it's being driven by some really influential organizations, particularly in Germany. Who are the main actors leading the charge here? Who's demanding this regulation?
Yeah, the primary organizations pushing this, based on the source material, are the Naturschutzbund Deutschland and EBU.
NABU, right. They're huge in Germany, aren't they? One of the biggest conservation groups in Europe.
Absolutely. Very large membership, very influential. And the other key player is the Deutsche Wildtierstiftung, or DWS. Their focus is specifically on native wildlife preservation.
Okay. And while they share the overarching goal protecting specialized wild bee biodiversity, do they approach it slightly differently? What are their strategic focuses?
They do have slightly different angles, yeah.
Yep.
Let's elaborate on MBU's approach first, as detailed in the sources.
Okay.
MBU tends to take the more comprehensive regulatory view. They criticize the density effect across all kinds of critical areas, but they focus quite heavily on the consequences of the boom in amateur and private beekeeping, especially in urban centers.
The rooftop hives we talked about.
Exactly. They're also highly critical of commercial beekeepers who place large numbers of colonies directly inside designated protected nature reserves, often doing so under the guise of providing pollination services.
Ah, using that justification.
Right. So NABU demands mandatory integrated wild bee support measures in all nature management plans. And crucially, they're calling for the potential introduction of quotas, actual limits on hive numbers, if scientific studies confirm that there's high competition density in a particular area.
So data-driven caps.
Exactly. Key personnel cited in the analysis, like Dr. Laura Breitkreutz and Konstantin Kreiser from ABU, they articulate this as necessary ecological load management, just like managing grazing animals.
Okay. And the Deutsche Wildtierstiftung, the DWS, you said their focus is a bit narrower, more scientific.
Yes, that seems to be their angle. The DWS focuses explicitly on the scientifically proven displacement effects and that mechanism of reduced wild bee brood success we discussed.
Sticking close to the biological impact.
Right. They position themselves very clearly as the advocates for the native unmanaged fauna of the wild tier. So their practical solution leans more towards specific, measurable regulations that directly address that impact, such as advocating for binding minimum distance requirements for all hives placed near known, established, important wild bee habitats.
The buffer zones.
Exactly. It's arguably a solution that's somewhat easier to define and potentially enforce than complex area-specific quotas. Just measure the distance. Hashtag 4.2, funding and independence.
Now, whenever we analyze a political conflict like this, especially one involving conservation versus economic interests or popular hobbies, we always have to ask, follow the money.
Crucial question.
The financial structure of these organizations, NABU and DWS, must be pretty crucial to their credibility, right? Especially when they're fighting a battle that involves taking on potentially established agricultural lobbies and the emotionally popular amateur beekeeping movement.
That's a really critical point, and the source analysis highlights this. Both ABU and DWS are funded primarily by a very broad base of civil society membership fees and donations.
So lots of small contributions from many individuals.
Exactly. And this funding structure is key because it ensures their operational independence.
Independence from whom?
Well, independence from state agencies that might be under pressure to prioritize agricultural output over biodiversity. And crucially, independence from agro-industrial lobby groups or large corporate sponsors who might have, shall we say, a conflicted interest in promoting pesticides or certain industrial farming practices.
Right. So their funding base allows them to follow the science wherever it leads, even if it leads them into conflict with, the public's perception of environmental heroes like the honey beekeeper.
Exactly. Their independence allows them to maintain a powerful critique of the entire system, not just tinker around the edges. Furthermore, these organizations tend to emphasize transparency to their donors.
Oh, so?
Well, the DWS, for example, makes a point of showing donors how their contributions are specifically earmarked. Your 50 euros helped undersow 2,000 square meters of farmland with diverse wildflowers, or this amount is dedicated to protecting peat bogs, or whatever the specific project is.
Okay, direct accountability.
Exactly. And this transparency helps stabilize their funding base, because donors feel a direct connection and see tangible results.
And that very necessity, the need to continuously appeal to a broad base of civil society donors, that also forces them into a specific strategic posture, doesn't it?
It really does.
They need narratives that resonate with the public and, importantly, demonstrate tangible success.
This is where the strategy pivots significantly, I think. The constant need for funding creates, perhaps inevitably, a preference for winnable local narratives.
Explain that.
Well, the fight against the multi-billion euro industrial agricultural sector and its associated pesticide use, That's politically immense. It's abstract for many people. It's incredibly slow-moving, potentially taking decades to achieve real change.
A marathon, not a sprint.
Definitely.
Definitely.
Successfully implementing, say, wild bee-friendly green roofs across buildings in Hamburg, or getting those high-density quotas established in a highly visible local nature reserve. That provides a measurable, tangible, local success story, something they can point to immediately. These local wins are vital for stabilizing their financing base through what we could almost call the economy of successful narratives. They need to show donors they're making a difference now.
Okay, so now we arrive at the political pivot point, and probably the most common counterargument you hear in this debate.
But pushback.
Many beekeepers, and maybe other critics too, accuse these conservation organizations of targeting a weak opponent, the local, often sympathetic beekeeper, instead of focusing all their limited energy and money on the strong enemy, which is industrial agriculture and the pesticide companies. It can look like a strategic distraction or even scapegoating.
Absolutely.
Yeah.
And this criticism forces the conservation groups to very clearly articulate their strategic defense. And that defense rests heavily on the concept of what they call ecological flight movement, leading to conflict shifting.
Okay, ecological flight movement and conflict shifting. Let's break those down. First, the ecological flight movement. Where are the beekeepers actually fleeing from and why?
They are, in this analysis, fleeing from the overwhelming toxicity and the floral barrenness of the conventional agricultural landscape.
Oh, okay.
Commercial beekeepers, especially, are economically rational actors. They have to protect their valuable livestock, their honeybee colonies, from chemical poisoning. We're talking neonicotinoids, other widespread chemicals used in large-scale farming. The financial losses from colony collapse due to poisoning are a huge business risk for them.
Okay, so they rationally avoid the vast flatlands, often dominated by just corn or rapeseed monocultures, where spraying is intense.
Exactly. They engage in strategic placement. They literally load their hives onto trucks and physically move them to areas they perceive as safer.
Safer meaning what?
Safer meaning areas that offer higher floral diversity, more things for the bees to eat throughout the season, and, crucially, lower chemical exposure. And the only places left in many modern landscapes that reliably fit this description are the last ecological refuges. Designated protected areas, often, as we said, small, resource-limited parcels of land in cities.
Cities with their parks and gardens and lack of broad-scale spraying?
Precisely. Cities have diverse, if sometimes patchy, floral offerings and are generally much less contaminated with agricultural chemicals.
Okay, so the beekeepers are rationally reacting to the failures and dangers of industrial farming.
Yes.
But in doing so, they are inadvertently concentrating their super efficient, highly competitive livestock right in the only safe places left for the already struggling, fragile wild bees.
That is the devastating conclusion drawn by the conservation groups in this analysis.
Yeah.
That's the core of the conflict shifting. The conflict caused by agriculture is shifted into the conservation areas.
I see.
So the demand for honeybee density regulation is thus interpreted not as an attack on beekeeping per se, but as a necessary reactive management strategy. It's framed as a countermeasure, responding directly to the colossal failure of national agricultural policy to secure adequate, safe pollinator habitats across the wider landscape.
So because systemic reform of the main problem, farming, is politically blocked or just moving way too slowly, the organizations feel forced to regulate the controllable risk factor, which happens to be a mellifera density in these last, most precious refuge habitats. Okay, essentially they're fighting a proxy war. They can't fight the massive systemic issue of agricultural policy directly and win quickly enough to save the wild bees now.
Right.
So they regulate the most visible and manageable consequence of that failure in the specific places they still have some influence or control over.
It's presented as an act of ecological realpolitics. Since the political system currently cannot or will not secure the necessary habitat required for all pollinators everywhere, the organizations feel they must secure the local niches and the critical hotspots where biodiversity still hangs on.
And the argument is, if they don't regulate the highly competitive livestock species, the honeybee, in these refuges,
then they risk losing the specialized wild bee species, arguably the most vulnerable elements of the native ecosystem in these refuges entirely. It's about preventing local extinctions.
and focusing on these local regulations allows them to achieve those measurable, localized successes we talked about earlier, which helps with funding and morale.
Exactly. It's a pragmatic strategy born from a difficult reality. #4.4. A strategy of cooperation, not feud.
Okay, but to avoid the narrative that this is just some kind of total ideological war against all forms of beekeeping, these conservation organizations must maintain a really delicate balance, right?
Absolutely.
They need to continue to cooperate with and be seen to cooperate with responsible beekeepers who ultimately share the same overarching goal of a healthy environment for all pollinators. How is that balance achieved in practice?
Yeah, that balance is maintained, and it's pointed out in the source material through the existence of broad environmental alliances. These alliances fundamentally counter the perception that there's just generalized hostility towards beekeepers.
Can you give an example?
A key example cited is the Network Blühende Landschaft, the Network for Blooming Landscapes in Germany.
Okay.
This alliance is powerful specifically because its membership includes MEU, the conservation group leading the density critique, but also organizations representing responsible, often organic or ecological beekeepers, like the group Mellifera, and ethical organic farming associations, like Demeter and Bioland.
Wow. So you have conservationists, beekeepers, and farmers all in the same network.
Exactly. The very existence of these kinds of collaborations proves that the underlying system, critique the shared attack on industrial monoculture, on pesticide overuse, is actually common ground across all these groups.
Right. They all want healthier landscapes.
Precisely. It demonstrates, or aims to demonstrate, that the criticism regarding honeybee density is surgical. It's specific to density management in particularly sensitive habitats. It's not intended as a generalized attack on the practice of beekeeping itself.
So the argument goes, if the wider agricultural landscape was actually truly blooming and healthy and safe, then this whole honeybee density issue in small parks and reserves would largely disappear, or at least become much less acute.
Exactly, because beekeepers would naturally spread their hives out across that safe, abundant terrain, following the resources, rather than concentrating them defensively in the few remaining safe spots.
So the common unified mission remains the creation of that blooming landscape for all pollinators, both wild and managed.
That's the ideal, yes. The conflict we're discussing is framed as being simply about how to best manage extreme resource scarcity in the interim during this emergency period, while that larger goal is still being fought for. Okay, so if we try to connect all these threads now, connect this analysis to the bigger picture, the synthesis seems pretty clear, both scientifically and politically.
What's the bottom line?
The arguments being put forward by groups like NEU and the Deutsche Wildtierstiftung, specifically regarding the competitive threat posed by high densities of managed honeybees. Those arguments appear scientifically solid, particularly concerning the survival prospects of localized populations of specialized solitary wild bees in certain environments. The data supports the risk.
Okay, the science holds up. But the conflict itself, this whole debate, it's really only a symptom, isn't it? It feels like a consequence of something much larger.
I think that's exactly right. You could say it's the fever that results from the underlying disease. This conflict is presented as a direct symptom of the extreme habitat loss and resource shortage that has been manufactured, largely, by the systematic and ongoing failure of agricultural policy across Europe and elsewhere to adequately protect natural resources and biodiversity.
So regulating honeybee density is, what, a necessary local measure?
It's framed as a necessary local measure, yes. A way to perform that ecological triage we talked about to lower the competitive fever in the immediate crisis zone, in the refuge.
But it's absolutely not the primary solution to the root cause of the overall 80% insect decline.
No, absolutely not. The conservation groups themselves would likely agree with that. The primary solution still lies in achieving that radical reform of agricultural practices, creating healthier landscapes overall. Density regulation is treating a symptom, albeit a critical one in specific locations. Hashtag tag 5.2. Necessary management actions in sensitive habitats.
Okay, so given that this radical agricultural reform is proving, well, slow to arrive at best,
Being generous, yes.
the conservation groups have to rely on actionable, local policy recommendations that derive from this scientific consensus on competition. What are the specific management actions they're demanding right now to mitigate the risk in these competitive hotspots, the nature reserves, the cities?
They tend to focus on proactive preventative management measures designed to secure the remaining fragments of biodiversity. First and foremost, they are demanding mandatory management plans for all designated protected areas.
Like state forests, local nature reserves.
Exactly. And these plans, they argue, must implement binding, scientifically recommended density limits and/or distance restrictions on honeybee hives placed within or near them.
taking the decision out of potentially subjective hands.
Precisely. It takes the decision out of the hands of individual park managers who might be swayed by, goodwill towards local beekeepers or perhaps small site fees rather than strict ecological criteria.
Okay. And what is the specific distance that the scientific study suggests is required to effectively secure the survival and brood success of the most vulnerable wild bees? We talked about the scale of competitive pressure. What's the necessary buffer zone they're calling for?
This is a crucial number that comes up in the analyses. Studies focusing on minimizing competitive overlap suggest a minimum distance of 3 kilometers.
3 kilometers between managed honeybee colonies and especially valuable, sensitive wild bee habitats.
Yes, and we need to understand the scientific rationale behind that specific, quite large number.
Why 3?
It's based largely on the geometric principle of non-overlap between foraging ranges. Remember, the specialized solitary bee is often limited to maybe 200, 300 meters from its nest.
Tiny range.
Tiny. While the generalist honeybee colony can send foragers out up to 10 kilometers, easily covering vast areas.
So if you put a honeybee hive just like 1 kilometer away from a sensitive wild bee nesting area, the honeybee foragers can still very easily fly into and heavily exploit the wild bee's critical 300-meter radius. There's huge overlap.
Exactly. The proposed 3-kilometer buffer zone is designed specifically to push the supercompetitor, the honeybee colony, far enough away so that its intense high-density foraging pressure on that limited resource patch right in the center is significantly diluted. Less overlap.
It gives the vulnerable wild bee population operating in its tiny 300-meter niche a fighting chance to actually secure enough local pollen to successfully provision its maybe 10 or 20 offspring cells.
That's the idea. Without that kind of significant spatial separation, the competitive pressure, especially late in the season, can remain catastrophic for the wild bees.
That 3-kilometer recommendation, though, it's a really stark reminder of the massive imbalance of power we're talking about here. A 3-kilometer radius circle drawn around even a small nature reserve takes a huge amount of land out of potential use for beekeeping production or placement.
It absolutely drives home the point about the scarcity of truly safe and resource-rich habitats remaining in the landscape. It highlights the pressure. The second major area of action is in the urban centers.
Right, the accidental refuges.
Exactly. Since city roofs and parks become these de facto chemical refuges, the argument is that cities must be compelled, perhaps by regional or national policy, to conduct proper urban density studies.
To actually measure the pressure?
Yes, to quantify the actual foraging pressure being placed on urban biotypes by the cumulative number of managed honeybee hives. And if competition is found, if the data shows that the local urban floral resource simply cannot sustain the current or projected density of managed hives without harming wild pollinators,
Then what?
then experts, like those at NEAU, suggest that the introduction of mandatory quotas is necessary, actual caps on the volume of colonies allowed within city limits or specific boroughs to protect the often surprisingly diverse urban wild bee populations surviving there. Hashtag tag 5.3. Recommendations for beekeeping alliances.
Now, the source material doesn't just criticize, it also looks forward. It seems to offer some quite constructive, strategic advice to the beekeeper associations themselves
It does, yeah.
on how they might be able to move this conflict away from being just an unnecessary feud and towards becoming more of a necessary cooperative alliance with conservationists.
Yes, the advice provided is really designed to help beekeepers potentially regain the narrative high ground and also pragmatically protect their practice from overly restrictive top-down state regulation that might come if the conflict escalates.
Okay. How can they effectively do that, according to this analysis?
Well, first it suggested they need to formally strengthen their systemic criticism, meaning IMCA associations, the beekeeping groups, should significantly increase their public unified alliance with conservation groups in campaigning against the conventional industrial agriculture sector.
Focus on the shared main opponent.
Exactly. If beekeepers are seen to be putting more pressure on the systemic problem, the lack of flowers, and the prevalence of pesticides in the wider landscape, then the perceived need for conservationists to restrict beekeeper actions locally might naturally diminish over time.
It makes sense. If the beekeepers actively help fix the main problem, the barren landscape,
Yeah.
then the secondary problem, the density issue in the refuges, becomes less critical. And the beekeepers are clearly seen as part of the solution, not part of the problem.
Precisely. It reframes their role.
Yeah.
The second key recommendation is maybe more immediate and relates to political positioning. transparency, and self-regulation.
What does that involve?
The idea is to preempt mandatory, often inflexible political regulation being imposed on them. Beekeeper associations should proactively, voluntarily provide data on their hive locations, especially in or near known critical areas for wild bees.
Share the data.
Yes, and perhaps even more importantly, they should develop and adhere to their own voluntary codes of conduct regarding density restrictions near known wild bee hotspots.
Self-policing, essentially.
Exactly. This kind of voluntary action signals that they are responsible custodians of the landscape, that they prioritize the health of all pollinators, not just their own valuable livestock. This sort of goodwill, combined with data sharing, could transform them from being targets of regulation into being seen as active, trustworthy partners in conservation efforts.
Wow. Okay. This deep dive has really exposed a profound and, well, deeply ironic truth right at the heart of modern conservation, hasn't
It
it?
feels that way sometimes.
The honeybee, arguably our most valuable, certainly our most recognized, and definitely our most beloved livestock pollinator, has, through no fault of its own species, become an unintentional yet powerful competitive threat. A threat specifically concentrated in the tiny remaining pressure cooker environments where its fragile, specialized wild cousins are making their last stand, taking refuge. It is. Well, it's a stunning illustration of just how distorted and incredibly stressed our natural systems have actually become.
It certainly is. And we've demonstrated, based on the strategic analysis presented in the sources, that regulating honeybee density in these specific places, cities, small parks, reserves, is what we call a winnable local action for conservation groups.
Right. It's achievable.
It's measurable. It arguably secures immediate, tangible biodiversity gains on a local level. And critically, as we discussed, it successfully helps maintain the necessary financial viability and the crucial mission morale of these conservation organizations who need to show progress.
They absolutely need those wins to keep the fight going on all fronts.
This raises a profound and I think important final question for you, the listener, to consider as you reflect on this whole strategic dilemma.
Okay.
If conservation groups are, in fact, being forced by funding necessity and by political gridlock on the bigger issues, to focus their limited financial and political resources primarily on securing these local, tangible, winnable victories, like managing a specific hive density in a specific municipal park.
Yeah.
Does that focus necessarily, perhaps subtly, over the long term, to attract political energy, donor attention, and maybe even public pressure away from the absolutely essential massive scale, but seemingly much more unwinnable fight? The fight for the radical agricultural reform that is ultimately needed to solve the root problem for all pollinators. It really forces us to ask, is achieving local success sometimes inadvertently costing us momentum in the global war for systemic change? It's a delicate balance with no easy answers.